What I'm going to do in this video is talk about the code that I posted here, the game state serializer. Now this code here, what I'm going to do to save time is to reuse or start off from the point I left off last time when I recorded a video for this input class, and this of course built on top of fonts built on top of this message overlay, or maybe fonts came before that, I can't remember. But in any case, this class here, which is the game state serializer, this is the purpose of this class is to save and load game saves. Alright, and what I tried to do is make this as as compact and standalone as possible without requiring too much from outside code. But it's hard to make that to get that to work completely as a standalone unit. So I'm going to show you it has some messy requirements on the main game class. I'm going to show that to you. So we're going to work this out. Here's the project that I was using last time. This is this message overlay example. I'm going to let's take a look at this. This, just to recall where we were at from last time. We have this game class, game 1, and we have a fonts class, or we call it init, pass in the content manager. And that loads the fonts that are in the system. The fonts were dropped in here in this content project, Arial 10 points, Arial 14 points. And then we want to initialize the message overlay class, and we pass in the sprite batch and reference, as well as one of the fonts, and we'll change that to 14. And then unload does nothing, and then we have update. And when we I'm going to simplify this. I don't have my controller with me right now, so I'm just going to use the keyboard. And it's pretty straightforward how to do this with the controller. And so we don't need the button presses here, just to clear that out. Let's just look at the keyboard. When the A key is pressed, we print A key is down. When the B key is pressed, we print B key is down. This message overlay class, just to remind everybody that the main purpose of this is not for so much for the user of the game, the player of the game, but for development purposes. And we call the base update method. This is very important to do. Many of the functions in the XNA framework, you don't need to call the base version of that function, but for the game's update method, it's critical that you call the update method. Then we have the draw method, and we call the draw method of the message overlay. Let's take a look at the program running. And here's the window. I press A, it says A is down. I press B, it says B is down, A is down, so on. There's a 5-second timeout on that message, so it'll scroll up like that. And let's kill that. So now what I'm going to do is just to illustrate this game save. What we'll do is we'll create a class called game state. And that'll be the container of our game state. And what we'll put in there is an integer, which will be the number of times we press the letter A. So here we go. So we'll call it A presses, and that'll be set to 0 initially, right? And let's go ahead and set the properties for that. I'm going to use this slick little tool right here to pop those in right off the bat there. And there it is. Now this class has to be declared, for all this to work, this is declared serializable. and it's annotated with this annotation. The class is serializable. Alright, that's the game state class. Now in the main game class, we're going to add an instance of the game state class. So here we have game state. Let's create an instance of it. Let's encapsulate that as well. Encapsulate the field right there. And maybe I should start using this. This internal, this means that classes within or functions within classes inside the namespace can access this. So that's the default. Let's take a look at what else we need to do. There's something else we need to do here, which is in the game, which is to declare another property. I'm going to do it here. It's a bool, and it's called waiting for callback. We'll set that to false initially. Let's encapsulate that one as well. That's very convenient. And what this does is when we interact with the storage device, we do it asynchronously. So we have to register this callback, and then we wait for the callback to be called. And during this time, we have to make sure that we keep calling the update method of the parent class inside this game class. So and then we want to do nothing else. We don't want to respond to our own user input and so on. So let's go ahead and look at how that's going to work. It'll look something like this. So we have this update method updates are the state of our keyboard. This records the state of the keyboard and the gamepad. It actually doesn't matter if we do this or not first or second. So I'll put this in here. So there's the test. If the guide is visible, we don't want to do any of this other stuff. We want to call this base update and then get out of here. We don't want to act on any user input. And what we're going to do is we're also going to add another condition, which is if the guide is visible, or if we're waiting for a callback to run and complete, then we're going to just call the update method in the base. So sometimes when you interact with the storage device, the guide pops up and prompts the user to select or insert a storage device. So that's important. And now when we press the A key, what we'll do here is we'll take our game state and increment the A presses. And then we'll print those as an integer. So we'll just print we'll display rather the number of times the A key was pressed. And when the B key is pressed, we're not going to worry about that. And let's take a look at that. Let's see if that runs. Let's take a look. Gamer services functionality must be initialized. So this is, I need to actually add that to my documentation. That inside, that this, here we're accessing the state of the guide. And this guide, you need to, in order to do that, you need to initialize what's called gamer services. And let's do that in here. And we'll do, actually what I've been doing is putting it in a try-catch block, because sometimes it's not available. And it'll look like this, I think. Let's try this. So this is, oh yeah, right, it's components. It's components dot, I'm going to try to do this from memory, and then you create an instance of new gamer services. This is a gamer services component, and probably, this is new gamer services component. I guess that's all it is, right? Just like that. Something is wrong. This should take the game class, right? So we'll just pass in this. Now, if the gamer services component, this can throw a, if you're not connected to the network, this will throw an exception. So let's see what happens here. So what we'll do here is we'll just print to our message overlay. Or maybe we'll just throw the exception, actually. Let's not worry about that. So if we want to handle that case, then we can do that. And without getting this gamer services component, we can't use we can't access the storage device. So there may be another way to do it, but this is the only way I've seen it done so far. So that would be critical. We wouldn't be able to save the game or load a saved game, even if we're running on a PC locally, if we didn't have a network connection. Alright, so let's try it now. Yeah, it looks good. So we had an exception last time, we don't now. So I'm pressing the A key. As you can see, the numbers are popping up there. I can press the B key, press the A key again. It's a 5-second timer on those. Alright, that's good. That works. Now, let's say the number, this game state right now, so the game state is simply the number of times we press the A key. So what we're going to do is save this and then load it. We're going to practice saving and loading. And to do that, we will create a new class. And this will be called, this one here, Game State Serializer. And I'm just going to grab all that code and paste it in there. It's not too bad. There we go. Copy that. Paste it in here. And now what I'm going to do is, so I'm going to have to get the namespace correct. It's not the hello namespace, it's the message overlay example namespace. Let's see if it builds. No, it does not build. And some basic reason here. Just double click on that. Waiting on callback does not contain a definition for waiting on callback. That's the game class. What did we call it? A waiting for callback, called a waiting on callback. Let's call it waiting on callback. And just to make the name consistent, I'll change this as well. Waiting on callback. There it is. Waiting for callback. This should be waiting on callback. Let's run that. So that's fine. Let's not going to do anything else. It runs. So what we do here is what we're going to do is we're going to make the S key a game save. And we're going to make the the L key a loading operation. So what we do here is we just go into the game serializer, the game state serializer rather, and call load. We're going to pass in the file name, and it's going to be game.sav. And whoops, that should be save. That's the load. This is L for load. This is S for save. So we'll do this. Now what will happen is this this save operation here has a side effect, and it first sets waiting on the call. So the first thing it does is it sets waiting on callback to true, so that this user input doesn't do anything anymore, and we just call update on the base. And then what it does is it waits for its callback function to be invoked, and then it reaches in here and sets the game state there. After it does that, it sets waiting on callback to false, so that the update loop can carry on as usual. So that's an unfortunate dependency, a very tight dependency, intricate dependency between the game state serializer and the game class. Another design would be to not use the game state serializer class at all, but instead embed its functions inside, and its variables that are needed also inside the game class. So that's an alternative design that can be done. As you can see here, we have a state declaration, and we have a load method, a save method. Then we have these private methods that are just particular to this. And one's called register callback. The other one is storage device callback. There might be one more. Here's another private method, get storage container. So we would need to embed these functions. Of course, we could get rid of this. That wouldn't be needed. And but we would have to embed those in our game class. But I think it's a good idea to resist that, to keep it separated out, because we want to keep the game class as clean and simple as possible. Of course, having this complicated dependency with the game state serializer doesn't make it simple, On the other hand, this waiting on callback, I called it, rather than waiting for storage or waiting for game save or like that, waiting for serialization operation, we made it general, waiting on callback. So there may be other instances where we want to basically shut down the game and wait for this asynchronous operation to complete. So we included that in there for that purpose. Alright, coming back to the game. Let's look what happens here. I want to explain this. So when we press the A key, we're going to be incrementing these A presses, which is stored inside our game state. And then when we press the S key, we're going to save the game. We're going to save it into a file called game.save. Now it goes in a folder that's given a name that's taken from somewhere else in the code right here. So we get, what happens is first we have to get what's called a storage device. Once we have the storage device, we get a storage container. And when we have the storage container, and the storage container corresponds to a folder on the PC. So I'll illustrate that. In fact, let's go to that right now. Let's go into the let's go into our documents. So this is Windows Vista, and I'm going to look at saved games, and you'll see that this is the path to a folder called saved games. Let's take a look at what happens when we run this thing. Let's see if it builds first. There it builds. So there we go. I'm going to press A a couple of times. I'm going to press S to save. Well, it looks like we got to do some debugging here. So it looks like a failed assertion in the game state serializer, the save method. So game state serializer line 57. There is a failed assertion. That's an assertion that I put in there. Let's take a look at that. 57. There it is. The game is null. We forgot to call a init. So you have to call a init to set the game. Let's put that back in there. Just going to close that. And we could do that in many places. We could do it right here. And load content doesn't matter really so much. It doesn't do much. It sets that. So let's put it inside this initialize method. So here with the game. The game state to serializer init, and we pass in a reference to this. Let's take a look at that. I'm going to press A a couple of times. I'm going to press S to save the game. Oh, another exception. Invalid operation. Message overlay is inaccessible due to its protection level. Only public types can be processed. System XML DLL right here. Game state. So those internal. Let's take a look at game state. And this should be public. I think that's it. Let's try it now. And I'm going to check that folder, see if there it is, the message overlay example. There it is. It created a folder. This message overlay example. That's the name of the game. And inside that folder with the name of the game, there's another folder called storage container. Take a look here. That's what we call it right there. So it's when we get the storage container. So here's the on the storage device, we invoke begin open container. When we pass in this name, it's going to either find a folder by that name or create one. I don't think there's anything in there yet. Oh, player 1. So we can do this for different players. Once again, we didn't specify a player there. And I think that's done when we get the storage device. Here's the storage device up here. Register callback. Here's begin. Here's storage device. It's a static method call begin show selector. We pass in the player number here. Actually, we need to generalize this. I think this might be a problem. If someone is using a controller that corresponds to one of the other players, so we might want to look at that. So we're going to have some kind of designated active player. Alright. So what was the issue again? I cannot remember now. It was an exception, right? Gonna have to run it again. Press A a bunch of times, press S for save, saving the game. Yeah, it's not a problem. I must have fixed it. So as you can see, I press save, and let's take a look at what happens. Under player 1, here it is, we created game save. Let's take a look at that. And I guess that one's okay. I'll just open that. And as you can see, it's an XML document. The root element is called GameState. That's the class that we're serializing. And it has these attributes which are related to the style sheets, XML schema. And then here it is, A presses is an element. Here's the start tag, A presses. This is the content or the value of A presses, and this is the end tag. So that's how the state of objects are serialized. They're serialized using XML, using the technique that we're looking at. I'm going to close that. Now let's run again and see if the load function works. Let's go ahead and look at that. So I'm going to press A a bunch of times, but now I'll press L to load, and I'll press A again, and you'll see we've restored the old version of the game. I'll press L again to load, press A again, you'll see we're just restoring the old version. That's it. So that's how the game save system can work.